Hey guys, good morning. According to our course convention, let's just wait for the other people for a couple of minutes and hopefully we can start in 5 minutes, say 11, well, no, 10, 5. Haha, I saw many good mornings from the chat. Yes, good morning, guys. Hopefully this is not too early for you.
Do you recommend disabling ASLR for the Linux machine that we're testing our binaries on?
1 second, come on, give me a second, sorry. Okay. Actually, test. Can you guys hear echo from me?
Not
No?
anymore.
Okay, nice.
All right. So what I really want to say is that for Camel's question, right now you don't have to disable ASLR. I think in futures challenge though, you probably want to disable ASLR.
Can you guys hear me now?
Yeah.
Okay,
Yes.
good. Yeah, so sorry, I was hopping between two devices, my iPad and my computer, and then I'm still not good at using both. So back to Camel's question. I think right now you don't have to disable ASLR, but in the future you will need to disable ASLR for some of the like stack or other kind of challenges. Then you should be able to hear me right now. Or is my sound okay? Good, nice. Thank you. Thank you for confirmation, guys. I really appreciate it. And 1 more minute, we will start. Okay, guys, let's rock. So welcome back to our course, CSE545, Software Security. And I hope that you have a very nice long weekend, although there's assignment. I hope you still enjoy either from the assignment or from the 3-day holiday. So in this week, we're going to continue reverse engineering. And for today's lab, we are going to walk through a challenge from our assignment. I know that many of you have questions about, how does challenge really work and how should I work on the challenge properly to get the result correct. So today I want to show you how I normally do it, but I want to emphasize that this is just like the way that I work on it. And as I mentioned in our videos, different people will have a different preferences. And I like to use GDB plus and reverse engineering tools such as Skidra or IDA Pro together. But someone just like to use some other decompilers like Hoppers, or they like to use other dynamic analysis tools. I know like IDA or Ghidra, they can also do debugging. I normally don't use that, but there are people love to use it. So feel free to choose whatever you like. And it's just like there's so many tools. It's like you are shopping around and finding your favorite product. So similarly, just try them all, and hopefully, I hope that you can have fun of trying them. Actually, for a lot of them, once you know how to work, how to use one tool, it's going to be very easy for you to know how to use other tools. So I would say the learning curve will be a little bit steep at the beginning, but once you touch one tool, the other tools will become much easier. It's like how you learn languages. Once you learn how C works, it's going to be much easier for you to catch up with Python or Java or whatever other languages. So before I start our lab, and which is our similar to what we have done before, this is our convention, is that I'm going to talk about the logistics. So assignment 2 is out. I think everyone knows about it, right? So the deadline is next Thursday, 11:59. So it's like the midnight of Friday. You can do this until the end of Thursday. And I intentionally make it on Thursday because I will, I want to help you out. If you have any questions in terms of the assignment, you can come to the office hour, come to my office hour or any of the TA's office hour and ask them questions. So make sure that you really utilize this chance well. And 1 hour ago, I just have an office hour with a bunch of you guys, and I walk through another challenge, which I believe will be helpful for you to understand how to use those tools. And this assignment has 2 parts. One is the X664 playground, which is the challenges in last week's in-class lab. So you see, I'm not really wasting any of your effort. When you are working on the in-class lab, you're actually working on your assignment. And again, this is going to happen for today's in-class lab as well. So besides the X664 assembly, you will also need to finish the baby key part in asu-cse545.com from that website. And for this particular one, first of all, there are 18 challenges over there. So if you haven't started, I don't want to push you, but I really encourage you to start early, because it's going to take some time for you to finish each challenge. There are 6 levels over there, and usually the challenge is the same level. They look alike with some slight difference, but it's going to take you some time to understand what's going on for each binary, and also to work on it to get the right answer. And everyone's binary is different. Also, everyone's key is different. And if you submit other people's key, we're going to detect it. So please be careful about that. Please not do it, because we don't want to catch someone by mistake. Again, the the URL is HTTP, not HTTPS for now, due to some technical issue, but it will be HTTPS. And if you have visited this website before and come across an error, and now if you just visit again, you may come across error again because of cache. So make sure that you clear the cache for this particular website, or open an incognito mode of your browser, or just like use another browser to open it up, and you will be able to get the website properly. If you do come across an issue again, even you use incognito mode or even you use another browser, please let us know, because we know that there is an issue for this website, and now we have to restart the server for every couple hours. It's not going to be an easy fix for now, unfortunately, but we will make sure that it will restart every couple of hours, so that you should be able to visit the website properly. You may come across a 502 for some point, but if you just wait for 1 minute or two and then refresh, you should be able to get to the website. Okay, so also I want to have a quick review, or say the overview for what we as TAs and instructor have come across in terms of the questions that we get from you guys. So we commonly get questions from you guys in terms of the assembly of x86-64, or like a Linux operation. So I want to emphasize that we are happy to answer your questions for x86-64 assembly, but this part is considered as the prerequisite for this course. So if you don't know assembly very well, I think you should self-learn, just spend a couple of hours to go over x86-64 assembly, and this will help you not only for this specific assignment, but it's also going to help you through the entire course, because we're going to use x86-64 assembly intensively across the course. So it's okay that you ask us those ad hoc questions, but more importantly, make sure that you can understand, you can read assembly by yourself, because this is going to help you. And I don't want this stop you from taking the course or finish the rest of assignments. Also, in terms of Linux, and also some of the tools like the GDB or say Ghidra, or like all the other kinds of reverse engineering tools, I'm gonna give you a view, like the way that I use it, but it's not gonna be systematic. You probably also need to explore how to use GDB or how to use Ghidra by yourself if you want to have a more comprehensive understanding. So there are some interesting videos online, like YouTube videos talking about GDB or talking about Ghidra, and I highly encourage you to check them out by yourself. It's not very long. It's also 10-20 minutes of a tutorial. You can just choose whatever one, just quickly go over them in case that you have some questions for how to use those tools. But today I'm going to show you how I use it. And if you can understand how I use it, and if you can follow it, you should be able to use the way that I use the tool to solve the majority of the assignments. Okay, so that's pretty much for the recap for what happens in the last week. So now let's start with today's lab. And there's no participation score for today's lab. We are gonna check we're gonna look at the first challenge in our lab. I know that everyone's challenge is different. So what I am going to do is that I am going to send you the binary that I have from my user account, and I'm gonna send you on Slack, and you can just download the binary from Slack and open it and run it. And if you already solved assignment 1, feel free to skip it. But if you don't, I really encourage you to stay and follow what I'm doing on this challenge, and play this challenge with me together. So now I'm gonna send you this on Slack, and please just wait me for a couple seconds, and then I'm gonna give you 5 to 10 minutes for you to play with this specific challenge. All right, guys, I just sent it on Slack in the channel of announcement. And let me know if you have any questions. You should be able to receive it very soon. Hey guys, a heads up. I am going to use Ghidra and GDB to show you how to work, how to analyze this binary. So if you want to follow what I'm doing step by step, you can install Ghidra right now. Or, and also you can install GDB if you haven't installed GDB. Guys, I'm not sharing anything right now. That's why you cannot see anything from my screen. But I will start share later on after this 10 minutes.
What are we supposed to do?
You right now just consider this challenge as what is shown in the in the website. So you need to crack this challenge in order to make your input correct. You should expect that this challenge should output something like you're correct if you're giving it correct input.
For the first challenge?
Yes.
Oh, okay. Is that the participation for class, or which one is the participation?
No, this is, as I said, this is there's no participation score for today's class, but this is gonna be part of your assignment. So everyone has, go ahead, sorry.
Do we have a participation for today?
No, there's no participation for today.
Oh, okay. I started on level 2, sorry, I was a little bit late for school.
That's okay. So everyone has a different level 1 in assignment 2. That's why I am sending you my level 1.
Okay, so just basically just work on the challenges right now?
Yes, work on the challenge right now.
So for the first one, I was kind of confused on the directions, I guess.
Mm-hmm.
And I didn't know what to expect, because it basically said to go up to 736 characters, I believe, but I wasn't very sure about the in terms of like working it so that it does match.
Yeah.
But
That's great. That's why, don't worry, Jose. This is exactly why we're gonna, talk about that in today's lab, in today's class. I'm gonna show you guys. Although the specific value will be different for everyone, the way that you solve this problem should be very similar to what I'm gonna show you.
Oh, okay.
So right now, just spend some time to play with the challenge that I'm sharing with you, and then I'm gonna walk you through and I'm gonna show you how you should solve this challenge.
Is this for CTF at ASU CSE545?
Yes.
Okay. I'm not sure where to go.
You will know it. Just wait for a couple minutes and then I will start.
Oh, okay. Would you be posting this recording?
Yes, I will. And guys, I have a question. Do you need me to show you just like a quick walkthrough of the website? If you need, let me know in chat so I can show right now. And for those that don't need, I can just let them, wait for a little bit. Okay, yes, I'm gonna show you guys. So for those that needs to help me show you the website, I'm gonna show right now. But if you don't need it, you can just turn me off. I don't know, like do whatever you like. Just like keep working on the challenge and give me 3 to 5 minutes, and then we can start the actual challenge. Okay, so guys, if you want to know how the website works, you can now start to look at screen. What I am showing to you is the website, right? So I know that many of you have registered. Do you have any question about registration? Registration should be fine, right? Okay, so I suppose that you already registered and you have already logged in. And by the way, I got asked about like login, password forgetting thing. If you forget your password, there is a forgot your password, and you can click it and it will send you a link. So here I'm gonna use my handle to log in. Okay. And I don't want my browser remember my password because I don't trust it. So here there are some tabs, and if you click challenges, you will be able to see all your challenges over here. And let's say this click one, this is one that I already saw. Actually, let me do the other one. Let's just do, like pretending. Let's start with the new one. So this is the one that I haven't solved. And then there's 3 buttons over there: run challenge, practice challenge, and download challenge. So if you want to run the challenge, so run challenge means that you can connect to that and then like actual run the challenge with your proper input. And once you get the input correct, it will give you a flag. So after you get a flag, you will need to copy paste your flag over here. And once it's correct, and after you copy paste it here, you submit, it will tell you whether or not your flag is correct. If we do practice, which gonna take some time, you will be able to again like connect to the practice server, but the key that you get from practice challenge will be different from the actual key if you run challenge. So the way that works is that for practice challenge, you will have root access. So you will be able to check the actual content of the flag. You will be able to get all the information. But if you run that challenge, you will not get the root access, which is the actual homework environment. So practice challenge is really that's like giving you more permissions so that you can know if there's something wrong or like how to make it work.
Can you show,
but then if you
can you show us an example in terms of that? It's just I didn't know how I would be able to like kind of decode or see some differences.
I mean, for the challenge itself, I will show you how to decode the challenge later on. But for practice challenge, actually, I have never tried practice challenge, but we can try it now.
Does it actually show you like, or at least how to get it right?
So this is practice challenge. So you said that like it says that you can run the challenge as a root. You can just use sudo, right? So here, if you do cat flag, you set permission denied, but if you do sudo cat flag, you'll be able to get the flag. But this is coming from practice. So you will have a way to behave as a root to get the actual flag information. But if you are running the actual challenge, and then now it's closed, you see, you need to reconnect. And for this time, you're running the actual homework environment. And in this case, if you do flag, you get permission denied. If you do sudo cat flag, it will not tell you. It will not tell you the actual flag information. So there's no way for you to get the flag, and you have to work on the particular binary correctly in order to get the flag. So if you manage to pass the binary, which I will show you how to work on it and pass it, you will be able to get the correct flag, and you can copy paste the flag over here, and it will tell you whether or not your flag is correct. Okay, so I think we are much more than 5 or 10 minutes, and let's start. I am going to go to the working directory. Yeah, and then this is the challenge that we are going to work on. First of all, you cannot run it right now. Oh, actually I can. Oh, no, because that is testing, sorry. This is teaching, level 1, teaching 1. I cannot run it, right? So it's set permission denied. So what you really want to do is to first change the mode so that you can execute it. And after you change it to executable, make the permission executable, you will be able to execute it. But here, if you run it, you found that it said there is an aborted, and then there is an error showing that assertion argc is greater than input arg failed. So now we need to look at why it fails and how to make it not fail, right? So what I'm going to do is that I'm going to use Ghidra to open this binary and understand and reverse engineer the binary. Before I start, I am checking the chat, and some of you are asking about SSH to the server with a denied permission. So you need to make sure that you have a key that has attached to your account. If you check the assignment handout, you will be able to see the details. Like I have a description of the steps, how to generate the SSH key, and then copy paste your SSH key to the website so that you can use SSH to connect to the server. So check the handout over there. Okay, so now I'm gonna run Ghidra. So if you start Ghidra from scratch, you will see there's no active project. And what I'm gonna do is I'm gonna create a new project. It's gonna be a non-shared one because I'm not gonna share that with anyone. Just say, let's see, lab week 4. Okay, and then I'm gonna import the binary, do import file. And it belongs to lab week 4 teaching. It shows some information about the import result in terms of this F binary. Just click OK. So here, we can double click this binary and it'll start. It will ask you, you know, this is the first time that you're going to analyze it. Do you want to analyze it right now? And yes. And make sure to click this. This means that the decompiler will also analyze the parameters of, you know, the functions of the binary. Okay, now it's done with analyzing. And let's go to the main function. You click the symbol tray, you click the, you know, expand the function symbol, and you will be able to find main. You can also just like type main over here, go to the functions one, you click it, and then you will be able to see function main, as well as the decompiled code of function main.
Let's see if it's good. I don't know if I want to move over there.
So once you have the decompiled code, you can start to look at the decompiled code and let's see what's going on over here. So you may still remember that last time when we run it, it says there is abortion, right? It says is a assertion arg greater than input arg fails. Let's figure out why this happens. And let's try to find this part of, you know, like popping up error message from the code. So where is it? It's right over here in line 37. And why does the program execute to this point? We found that there is an if statement, right? So the if statement says checks if parent 1 is smaller than hex 6b. And if so, it will pop up this message telling you there is a failure in assertion. So the question is, what is param 1? Let's scroll up. Scroll up. So param 1 comes from the main function. The main function of GCC, sorry, the main function of C usually have, you know, like typically have 2 arguments. It can have 3 arguments depending on if you have a, you know, environment variable. So here, the first argument is always argc, which is the number of arguments. Let me change the name of this parameter so that we will be, you know, it will be easy for us to understand. Change it to argc. And then the second one is usually argv, right? Okay. So now we see that here it just output argv, and later on the second part is it checked argc and compare that against hex 6b, right? So here, if argc is smaller than hex 6b, then it will pop up an error. So this means that we need to give them argument for this executable, and we have to give it a lot of, like, you know, arguments to this particular binary. We have to give more than hex 6b arguments. So how are we going to do that? So we want to give, you know, it's like 1, 2, 3, 4, and to hex 6b. That's number of arguments. It's going to be very hard for us to really like type a lot of arguments over there. And the way that I am going to do is that I am going to use a bash command to output a number of arguments. So what I'm going to do is I'm going to do for I in SQL. This is say hex 6b, but let me just make it a little bit longer because argc also includes the like the includes the path of the binary. So the first argument of the entire execution would be always the path of the binary itself. But here, just to be safe, because it doesn't really care how many more arguments that I give it, I'm always just giving it a little bit more argument. So do done, and then I'm going to do echo. In this case, you will get a bunch of arguments you see over there. So we already have those arguments, and then we're going to pass it, pass it as arguments to the binary. So what we're going to do is we're going to do a pipeline and do X arcs, and then teaching. Good. So now we got a different error message. Oh, before I go on, let me just quickly check the chat. And meanwhile, you guys can try this command and see if that works in your Linux. I'm gonna give you, say, 2 or 3 minutes while I am going to check the chat questions. So Daniel is asking a very interesting question. I have come across this problem as well, like how to fix a 4K monitor problem in Ghidra. So let me show you what I do. Daniel, so what I do is you need to go to, yes, exactly. You need to add scale, and also you need to have another one, which is, oh, actually I forget. It's inside length.properties. There is also like a dsum.java2d some option.
Were you working on the testing, or were you working on the teaching?
I'm working on the teaching, and I'm working on the binary that I share in Slack, because everyone's binary is different. And in our lab, we're gonna use the same binary, which is the one that I shared in Slack announcement. So check that out. So Daniel, I'm pretty sure that sorry, Abhishek, sorry if I pronounce your name wrong. Abhishek solution will work. This is how I did to like zoom in and like increase the scale by 2, and it works for me. So for Elia, the website is not down. You probably want to open an incognito mode or use another browser to open the website. Oh, okay, it's back up. Nice.
Professor,
But
one question.
Yeah.
So why do you make changes in the variable name?
Sorry, why do we change the
why
variable?
Yeah. So in the code.
What do you mean by variable name?
So you made changes in argc, right? Argument C from param1.
Oh, you mean how to change the name?
Why did you change it?
Oh, the reason why I'm changing it is because I want to make it easy for you to understand. You don't have to change it. If you know that this particular argument means like param1 means the number of arguments from the binary, then yeah, if you know it, you don't have to change it. It's just like for an understanding purpose.
Sure. Thank you.
Yep. Okay, guys, I am gonna continue. So now we see an error message over here, right? We see it says that the challenge has shown read, and then after skipping some bytes to make things a bit more complicated. Specifically, it skips 0 bytes. The data it reads in was this, 31 followed by 30. So it says that the mangling is done. Now the resulting data is again 31, 30. But to verify that your input is the correct license key, the program will compare this, which is 3130, against the following expected result, which is 7777. So we need to make sure that the bytes that we put into the argument is equal to 7777 so that it will work, right? So now I'm going to show you two ways. One is very hacky. The other will be less hacky and will and also show you how we're going to use reverse engineering to find exactly the bytes that are associated to the 77, and we can find the correct key or the correct input that we need to put. So I'm going to show you the very hacky one first. And I want to say, this one is hacky because this is really, really program specific, and this is only work for this specific one, because right now here, the expected results showing over here is same. So we don't really care which argument is 7777. All we care is that there is 77 and 77. So let's just make our arguments always equal to the value of 7777. So the question is how to echo, how to print a character 7777. I am going to turn on my Python and then see if 77 is printable. Actually, it's printable. It's W, right? So what we're going to do is going to echo character W over here. Okay, so this case, it still says it's wrong, right? But it says wrong is because this is 77 followed by 00. So it must be because right now the argument that we're putting is one character. It's one character W. So that's why if you look at the C string, it's gonna be 77 followed by 0. Let me just put one more character over there. It is correct. So in this case, we don't really need to understand what's going on with this particular binary. We just looking at the error message, and then we know that all it wants is have an argument, although we don't know which argument it is, but we know that the expected value for this argument is WW, corresponding to hex 7777. And then, we just put all arguments equal to WW, and it works. Now I'm gonna pause it for a while, and you can work on this by yourself. Try this command and see if you can get the correct flag. By the way, you may not be able to get the correct flag, but you will be able to get this message. And the reason why you will not get the flag as what I show here, 1, 2, 3, is because you don't set up a specific file directory. Like you don't have that flag set up in your system. So when the program tries to read that file, the file doesn't exist. That is fine. As long as you can get this message of correct, here's your flag, it means that you're correct.
I have a question.
Yes.
I also wanted to try to run it with GDB, but for some reason, when I try to set a breakpoint, it doesn't actually set it.
So you can run it properly. Okay, I see. Yeah. So you asked me this question in office hour, right?
I think I didn't answer this. I didn't ask this question. No.
Oh, sorry, it was another person. Sorry. So I don't know why, but I can help you out later on. I think this is probably a specific question to for your system, because right now, if I run GDB, with this binary, as you see over here, I can run it, baby key TG, and it runs. So you probably, I will need to know more details, like, what is the error message, etc. And what if you talk to me personally later on, and then I can help you figure it out why it doesn't work on your GDB. Okay, guys, now let's continue. So let's assume that we're ready. Let's assume that, we just don't know this hacky way to solve this problem. So we really want to take a look at the binary itself and understand what's going on over there. So let's go back to our Ghidra view. And then first, let's find the place that it says, correct, here's your flag. Because that is the target for us. We really want the program to execute that part, right? So here comes line. So it turns out that line 83 is the line that outputs correct. So we want to get to here. And in order to get to here, we need to make in FD that's particular arguments equal to 0. And this argument is assigned by starting CMP, starting comp, comparing local 23 with string WW and length of 2. So the question is, how does this local 23 come? Where can we assign a value? How does this local 23 got assigned a value? So let's find a place that local 23 is assigned with a value. So we need to go up, find argument local 23. It's right over here. There is another way for you to try it. If you click this and then right click, there should be a slice, or maybe it's over here. Okay, I don't know why local 23, there's no def use for this argument, but that's fine. We can just go up and find it by ourselves. Just eyeball this, read the compile code, and we'll be able to get local 23, which corresponds to the upper side. Where does it? I saw it. Hold on. Oh, it's right here. Line 30, right? So local 23 is equal to argv, and which is the, with the offset of hex 6a. So that means that we want to make the 6a argument equal to WW. So now let's work on this together. Remember, this is hex 6a. So what we really want to do is to have, it's like a couple parts. For some parts, we could start this to 6a, but we know this is not gonna be not enough because the entire program needs more than just 6a. It needs 6b, argc6b. And let's do it. So here, I didn't put more information over there. I didn't put more argument. And this is because hex 6a is actually the last argument from the binary, because as I mentioned before, for argument for argv, the first argument is always the argument is always the path of the binary itself. So followed by the first argument, which is the second argument, are those arguments that I put over here. So that's why if I have 6A arguments plus the first argument, which is the path of baby key level teaching 1, I will have 6B argument, which satisfies the condition, which satisfies the check of the number of arguments has to be greater or equal to 6B. So in this case, I will be able to solve this challenge again. Actually, you may need, all you need is the last argument, which is the the hash 6/8 arguments equal to WW. So if you check the other argument, so if you check this to say 6/9, make it equal to AA, and then you do echo again. Oh, this doesn't work because I am passing that to I didn't pass the WW to the end of this particular program. Let's do it another way then. So this way, I'm going to use Python instead of bash command. So we're going to do Python-C, means that I am going to type some Python code over here, and it will run the result and output. So what I'm going to do is I'm going to do Python-C, and then print, say AA times, actually I need to do a single quote because I already used double quote outside, times AA space, and then plus WW, single quote again, so it works again. So if you remove the pipeline, you will be able to see what I do here. So this part of the code, it just print all those, like word as AA for hex 69 times plus the string of WW, and then it fits it to the binary. Sorry, there was a typo. So this is another way to make it work. And command-wise, you don't even need to use pipeline. What you can also do is to remove this pipeline and then just try it in this way. But here, we're going to add a backquote, meaning that we want this part of the code to execute. You can still get it. Okay, yeah, so this is another way for us to get this binary, get this challenge. And the way that we look at it, like the way that we solve it, is to use static analysis, use a decompiler to understand what is needed for for passing the check, and then put the specific argument with the specific value. Okay, now I'm going to pause for a while and have you try those Python command or like bash command. And later on, I'm going to use GDB, another way to solve this challenge.
So you said that for today we don't have a lab, right? Like last week.
Right.
Okay, I just wanted to make sure. It's just I'm gonna go do something, and I'm gonna make sure. I just don't want to get in trouble, in terms of points.
Yeah.
Okay. Bye.
So yeah, in terms of this challenge, you will not get the flag value but you will be able to get the correct message. And the reason why you don't get the correct value is because if you look at over here, look at the decompiled code, it says that if your input is correct, then it will open a file in your own system, like in the system that is running this binary. And the system, like the file is /flag. So if your system has this, has this file in a /flag, has this file in this directory, you will be able to open this file and maybe output something over there. But usually you don't have such flag in your system. So that's why once the program executes to this point, it will probably raise an error saying there's no such file or directory. But as long as you get this, that means that you're doing this correct. And if you run this binary challenge in your own server, like in your assignment server via SSH, you will be able to get the correct flag value.
Professor, I have a question.
Yes.
So why do we need to do the SSH? So we are downloading the file locally and then solving it, right?
So if you need to use first of all, you can download the binary and run just as what I'm showing you right now. But after this, you need to go to SSH, you need to go to the server via SSH so that the server will have this flag file. So this is exactly the reason why you need to access the server to run your your input correctly, so that the server will read the flag from the server and show it to you in terms of your flag value, so that you can copy paste the right value into the system to show that you're correct.
Sorry, Professor. Can you please demonstrate that part? Yes.
Yeah, sure. So in this case, I know that this is the way that I can make it work, right? So I'm gonna SSH to the server. Let me see if I still have it. Okay. It's here, right? So I'm gonna go over there. Oh, this is testing. Hold on. I need to go to teaching. This is the right server. And then the teaching binary is over there, right? And then what I'm gonna do is I'm gonna copy paste this command over there. And then it will say, correct, here's your flag. So you got this flag. And then you can copy paste it to the web. Up here, it said I already solved it because I already solved it. But if you haven't solved this, if you click submit, you will say, it will pop up and telling you that you are correct.
Okay, thank you so much. Sure.
Yep. Okay, guys, now let's try to use GDB to solve this problem. So let me.
Hello, Professor. I have one question.
Yes.
What was demonstrated was that while we cannot access the flag file just like that on the server because our user doesn't have the privileges, a binary can output the flag file.
Yes.
Regardless of which user runs it.
Right, exactly.
So like if you're allowed to make files on the system, wouldn't we be able to just make a C program?
Exactly. Yes, yes. Like if you have the access, you have the permission to read the flags, the flag file from the system, then you can just read it by yourself. But that's why, for practice server, you can read it. But if you're running the actual homework server, you cannot read it. You have to read it through this particular binary.
Right. So if we were able to make a binary of our own on the actual server, wouldn't we be able to access the flag file?
Are you saying that if you have a binary on
like
the
if
server?
we make a custom C file and make a binary out of it?
That's a great question. I believe that the way that the current permission that we're setting over here, you will not be able to upload a binary and run the the cat flag or something like flag rating over there because you don't have the permission.
All right. Yeah.
So am I correct? The binary has a set user ID for root. Is that correct?
Yes.
Or for
yes,
higher
yes.
permission.
Okay, yes, yeah. Exactly. You got it.
Oh, that's all right. Yeah, that answers my question. Thank you.
Yep. Right, and I will talk about set UID, those those part of the setup probably in this week or next week's video. I'm still planning for that, but yeah, I mean, I will talk about that later on, so you will understand why this happens, why you have to go through this particular binary to read the files over there.
Yeah, sure. Thank you.
Okay, guys, now we're gonna look at the use GDB, and if you see my GDB, okay, now I'm gonna check this out. First of all, I just do GDB, right? And if you see my GDB, you will be able to see that this is not the typical GDB that you are using because I am using PongDBG with GDB together. And this is a GDB plugin that I mentioned in the video. And there are also other choices. So you can go for whatever you want, but for this particular lab, I'm gonna just use the fundamental feature. Like those commands, you should be able to run that with plain GDB. So you don't have to really install PongDBG right now, although I will highly encourage you to install one of them after this course. Okay, so I am going to do GDB and then baby key. You can, inside GDB, you can run this binary, but I usually just start it from outside because in this case, when I do run, I don't have to type a lot of characters later on. Okay, so now we're gonna run that, and so if we're gonna run it with just run, it will set that it fails. There's a lot of information over here. You don't have to look at it right now, but you see a Sega board, right? and you will be able to know where it is. So the way that I check is usually just like ps.ps. This will tells us the address. PS means the program pointer, like the current instruction, the current address that the program is executing, which is at hex 246. And then let's take a look at hex 246. None of it is over here, right? And that is very interesting. The reason why is because if you look at the call stack, right now when it stops, it stops at the inside of the abortion. So what we really want to do is to jump out of the upper frame. So we need to do up, one more layer, one more layer, one more layer. Okay, so here we go. In here, this is the address that actually we're coming across. So, which is this part, it's called assert and fail. We know that this is the place that we stop at. And now if we click here on the static assembler, or Ghidra in this case, it will go to the specific decompiled code that contributes to the assertion. So now you will be able to know this is the place that it stops executing, and we have to make argc is equal to this particular value. So now we know it that we have to put a lot of argument over there. Okay, now let's quit. And then what we're gonna do is we are going to set args. Okay, that's correct. And then put the python-c, say, what is the value? 6b. Okay, 6a will be sufficient. Okay, now let's run it again. Okay, so in this case, it says there's no flag for you, it's wrong, right? And we can figure out why it is wrong. And remember that last time we were checking this static, the decompile code, we know that the critical point is at this place. We need to make this stir in comp correct. And this corresponds to instruction of B73. So we need to set a breakpoint over here, B73. And for GDB has a specific base address when it loads a, like a PIE, like a instruction independent programming stranded place. So we need to, a program, so we need to add this base. Honestly, I just can't remember the base name because it has so many files and I can't remember how many files in that base. So what I usually do is I'll just set the breakpoint at main first. And it will tell me the base value, which is this. So I will just like set this followed by the offset, which is B3E in this case. Sorry, B73. Okay, and then I'll just delete the first breakpoint. And I'm going to continue. Run it again. Okay, now it stops over there. It stops at the instruction. And you can see the instruction here. And it's telling you that what it's comparing is the first argument at this place. By the way, this is the nice thing of Pong DBG. It gives you the argument. It already parsed the argument for you. But if you are using GDB, you will not be able to see that. It's fine. What I'm going to show you is that you can do a x-i $PC. It will show you the current instruction, right? And then if you want to get the register, you want to get the argument, you need to remember that according to calling convention, the register for the first argument is RDI, and the second is RSI. So you can parse the value of, say, some characters. RD. I just put a random number. I put a random like a value, 10 over there. You can put whatever you want, and then RSI. So now we see that it's trying to compare the argument between this AA and WW, right? And then the next for you is to figure it out this AA, where does this AA comes from? And there is a way for you to check it, like for this specific challenge, because it's easy. It's just do a very plain, like there's no mangling, there's no like change of the input. So what you could do is that you can just change this. Instead of AA, you can just put it to some value so that every argument is, every argument is different. So you could do is okay, print join Python 2. So first of all, let me check if this is correct. So what I am going to do is Python-C print okay. So what I am doing right here is to print each argument and then print each argument as the number, as the index of it. So it's like the first argument is gonna, sorry, actually, if you look at the binary, it's gonna be the second one, but here I'm gonna just put 0 over here, because what I really want is just like every argument maps to a unique value, so that when I look at the comparison later on, like here, I can realize which argument that I need to change. So now what I'm going to do is I'm going to do GDB args and then baby key level teaching and put this, right? And then last time, I already forget the address, but I can copy paste over here. So I'm going to do run it. Okay, it stops over here. So now we are able to see where it comes from. So let's check the value of RDI. It has 1, 0. And then the RSI value, again, this is WW, right? So which string contains 1, 0? Actually, there are quite a lot of them. If you take a look at what has output from Python, 1, 0 can happen on, from here. It can also happen from the arguments, this part. So the next that you can do is that you can just change the value over here until you find the value in RDI. Sorry, the value that RDI points to corresponds to the change in your argument. So you will find the mapping between the argument and the value that RDI points to. You will be able to identify the correct argument and then change it to the right answer. All right, because of the time, I am not going to show this part, but it should be easy for you to test, since you already have those, command coming from Python and GDB, and you can try it in this way. And in this particular case, actually using GDB is not the fastest way, because understanding the code is much easier. However, if you are analyzing on other binaries, you will start to realize that actually running the code with GDB is going to be help you to understand, because you don't have to get a whole picture of this entire code. So for example, the one that I was looking at with students during my office hour, this is a one in terms of environmental variables, and turns out that using GDB to debug will be much easier for you to identify the critical part of the environmental variable so that you can set it with the correct value. Okay, I think that's pretty much for today's lecture.
Professor, I have one question. Can you quickly demonstrate how to run a program in GDB with or how to do it while modifying the variables, the environment variables?
Yeah. So so now I'm in GDB, right? So what you need to do is set inf environment, say, just like whatever, cast in variable equal to a value. In this way, you can set in environmental variable.
Awesome, thank you.
Yep. Okay, guys, I'm gonna stop sharing, but you can still stay and ask me questions. Kamal, I will set up a break room with you, and we can figure out your question for the GDB, your issue.